So at this point you should be comfortable with descriptive statistics and the process of inspecting variables and even multiple variables together to understand relationships, differences, and so forth. So we've discussed descriptive statistics in the last session. In this session we're going to start to get into univariate and bivariate analysis. Specifically we're going to focus on univariate. And univariate simply means that we're analyzing one variable at a time. You might wonder, how could you analyze one variable on its own? Usually when we think about analysis you think about correlations and regressions and things like that. But there are actually two really important tests that we'll look at in this session. The first is a one-sample t-test. With a one-sample t-test you're trying to determine whether there's a difference between the mean value for a variable and some reference value. So to illustrate this, let's think about one of the questions we asked in this rent survey. Decor 1. The question was asking folks to agree or disagree as to whether or not they believe that they enjoyed the decor and design of their apartment or condo, wherever they lived. So let's think about the possible response options for this. This was a scale from 1 to 7. And so people were picking a number from 1 to 7, indicating whether or not they strongly disagreed or whether they strongly agreed. So we're going to get a bunch of responses, and we're going to have a distribution of responses. And let's say the distribution of responses looks something like this. Alright, and there's going to be a mean value. I don't know what that is yet. We'll find out in a second. Well, let's say the mean value is 4.8. So here's a question we could analyze statistically. Remember that with a scale from 1 to 7, 4 is our neutral point. 4 means I don't disagree or agree. So the question we could ask is whether or not 4.8 is statistically different than that neutral value of 4, or more specifically, is it statistically higher than that neutral point of 4? So let's switch back over to our rent data and figure out how we do this. So, univariate test of difference. What you want to do is go up to the Analyze tab. We're going to do Analyze, Compare Means, and in this case we're doing what's called a one-sample t-test. So let's look at this variable decor that I mentioned. This is a scale variable. Now here's the important thing that we want to do. We want to say that we want to compare the mean value for this variable against some test value. And it depends on the question what would be a reasonable test value. You could test to see whether it's significantly different than any of the numbers. But what conceptually makes sense in this case is we want to know if the mean value is different from the neutral value of 4. So we'll put in the neutral value of 4. So here's what we get. Actually, in this case, the mean value, and we could have noticed this if we'd inspected it first visually, but the mean value is 3.97. So we could probably have guessed ahead of time that that wasn't going to be statistically different than 4. Let's go ahead and look at the rest of this table, because we're going to be able to understand a lot from this table, and it's going to be important to be able to interpret these statistics. So the first thing you want to look at is relative to that mean value of 4, we're comparing that 3.97. This table is telling us right here our test value that we entered in was 4. The mean difference between this test value and our actual mean is 0.031, negative 0.031. And the question is this statistically significant? Well, here's the answer. There's the t-score. That's something you would have hopefully learned to have calculated in your statistics class. The t-score for a given degree of freedom And degrees of freedom you can think of really as your sample size of 64, in this case minus 1, so degrees of freedom is 63. And here's the significance. It's 0.898. That means in this case it's not statistically significant. For statistical significance, really we're looking for values that are below 0.05. So, statistical significance. Here's what we can say. If something is p-value of less than or equal to 0.05, then we can say it's statistically significant. That's a good thing. However, if we have a p-value that is so how do we interpret p-values? Well, if we have a p-value, that's a lowercase p, that is less than or equal to 0.05. Conventionally, this is the level at which we can say we have found statistical significance. So ideally that's what we're looking for. And usually you would report p less than or equal to 0.05, or if you had something that was less than or equal to 0.01, you could state that, or ideally 0.001. But this is usually the maximum threshold. However, just to be complete, what happens if you have a value over 0.05? Is it not significant? And again, here's what we typically say. Is if the p-value is greater than 0.05 but less than 0.10, then we can claim that that statistic is marginally significant. So that qualifier is important. It is marginally significant. On the other hand, if you have a p-value that is greater or equal to 0.01, then it is non-significant. So let's say you had a p-value that was 0.12. Could you say that, well, that's kind of approaching significance? Not really. You want to avoid that. In fact, just don't do it. So if it's p less than 0.05, statistically significant, between 0.05 and less than 0.10, marginal significance. Anything greater than that, non-significant. Okay, so let's go back and look at the result here. 0.898. So we're way above that non-significant result. So we conclude from this that we cannot reject the null hypothesis. The null hypothesis in this case is that there is no difference. So that's what we found with D1. Let's try another variable and see what we get. Alright, for this next one, again I'm going to do analyze, compare means, one sample t-test. Actually, before we even do that, maybe we should go ahead and let's try to visualize this data. So let's do analyze descriptive stats. I'm going to pick a different variable this time. This is the rating. It's one of the questions about neighborhood. And specifically, if we look at the neighborhood question, the question was rate the degree to which you agree or disagree that this neighborhood is a neighborhood that people really like to live in. So take out rent, which we had in there before, put in decor, and really I don't care about statistics, I just want to look at a histogram. So let's try a different variable now. I'm interested in this neighborhood 1 variable. But before I do any analysis, so let's try a different variable now. I'm interested in this neighborhood 1 variable. But before I do any analysis, why don't we go ahead and visually inspect this variable first. So I'm interested in this neighborhood 1 variable. Neighborhood 1, the question here was rate the degree to which you agree or disagree that this is a neighborhood that people really like to live in. I want to see my mean. I'd like to see a histogram. Okay. Now what do we get? Well, the mean of this one is 5.22. So it seems like if 4 is neutral, the people are leaning towards agreeing that they live in a neighborhood that other people would like to live in. So 5.22 seems to be significantly bigger than the neutral value of 4, but is it? Well, we can go back and actually analyze this and find out. So back to analyze, compare means, one sample t-test. And again, we're going to keep in our test value of 4. And that makes sense because our range was 1 to 7, with 4 being our neutral point. And now what do we find? So now let's find out if it's statistically significant than the neutral point. Again, analyze, compare means, one sample t-test, and we're using this neighborhood variable. And what do we get? Well, here's our test value of 4. Our mean for the actual data was 5.22. And so the mean difference is 1.219. So is that statistically significant? And the answer is absolutely. Now technically you can't have significance of 0. What this is saying is that it approximately is 0. So it's probably 0.0001 or something like that. So in this case, how would we actually write out the statistical significance? We can say it's statistically significant, but what would we actually write? Well, we'd probably want to include in the statement that the mean value of 5.22 is 1.219 greater than our test value. So that would be the first part of the statement. The rest of it would look something like this. You would want to specify your t-score, your degrees of freedom, and this would actually be your t-value. And then in this case we had p less than 0.001. So that's the format for reporting a t-value, whether or not it's significant. Alright, so what we can do is go back to the table and find out what values to put in here and here, and we already knew what we were going to put in this one. Alright, so this is the value that we would put under the t. This is our degrees of freedom, and we already had in there our significance.